Good morning, everyone. As so nicely introduced, I'm Paul Angus from Shape Blue, and today I'm going to be, well, right now I'm talking about complex networks and giving some thoughts around that and sort of showing what we're doing in the CloudStack world about it. A very brief summary with the that number that keeps ticking up there of how many years I've been doing this kind of thing. It's getting depressingly high. But basically, I work at Shape Blue, and my main focus is looking at what everyone's trying to do with CloudStack, what our customers and just general conversations are, and then trying to see if I can see a pattern and something that would be of use and interest to people that we might not have thought of before. So this, with complex networks. I'll start off giving an idea of what I'm talking about when I'm saying a complex network. Then, because it kind of fits in, a slight digression into NFV in the virtualized world. And then talking about what we've called, for want of a better name, next generation networks, because it kind of sounds catchy, but it's also has got real uses in the real world. Then it goes nicely into layer 2 networks with, again, another slight digression into config drives, and then just a quick roundup and look at what we're trying to do next with those networks. So, the first step, I guess, is to talk about what complex networks are in the first place. And what really I'm talking about here are things that don't fit into the classic CloudStack. Here's a router and a network with stuff on it, or in the case of the VPC, a router with a couple of networks all coming off that. And we do take a bit of a, well, you do it our way or the highway in terms of what you can do with networking. We've got a very specific way that networking kind of works. And most corporate networks, enterprise networks, just don't look like that. They've got quite a different look and feel. So just trolling around on looking for images of nice little diagrams of people's networks. When you look at these, you see they don't really look anything like what we would normally put together in CloudStack. And we've got people who do specialist kind of networks that do specialist jobs. I think I'm trying to see what the guys from Virtualized are here. I know they're doing really interesting stuff with network appliances and using CloudStack to drive implementing network appliances in their infrastructure. And then also we have the kind of holy grail that people talk about and look for, which is the hybrid cloud. How can you really have CloudStack working with all of these other kind of clouds, or on-site, on-premise networks, all sorts of branch offices? How can you make CloudStack fit in with all of these things? And I said about our virtual router sitting in the middle of it. One thing that is important in these complex networks are the virtualized appliances that all the major vendors have now. They all have a virtualized version of the physical appliances that people would have been putting in their data centers. They all see that virtualization is the way this is going largely. And so they've all produced variants of their appliances that are virtualized. And if you remember, for instance, the Citrix NetScalers, the VPXs have been about, God knows how many years, as long as I can remember, that has been about as a thing. So they've long kind of embraced that idea, and everyone else is getting in on the act as well. So, I'll then, only slightly off topic, have a talk about NFV, because it's the big marketing thing that people will talk about in terms of putting these appliances into networks. And the key really with NFV is you can deploy one of these appliances really easily. You get the template of the virtual machine and you start it up, and there it is. And then you sit there configuring it and connecting it. But obviously in our software-defined world, we really want to be able to automate that. We don't want people sitting there at consoles having to do these things wherever possible. So NFV, which are network function virtualization, i.e. the thing you're trying to do virtualized, came about. And the real problem is that because you saw just a tiny list of appliances, you have a great big list of appliances, they all work in different ways, and how do you basically orchestrate all those things? So there is a standard, an institute that's trying to bring about a standard where all these things talk to each other, and unfortunately it looks something like this. You have multiple components in here, all of which work together to try and allow your, whatever it is, your Cisco ASA-V and your Viata or Brocade vRouter all to live nicely together. And when you look at it, you've just got this one instance here, which is the virtual instance. That is actually the thing that everything else is trying to give you. It's the Cisco ASA, as I said, or a Juniper VSRX. It's whatever that thing is, just sitting in there. Now that vendor will have what they call an element manager, which is the thing that then passes configuration data and health checks to that system, because it is proprietary. 9 times out of 10, whatever that thing is, it will be proprietary, and so they create a proprietary thing to talk to it. However, the interface between that element manager and what we call the virtual network function manager now becomes standardized. So there is this standardized piece in the middle, which basically connects the two things together through a known channel and a known principles of working. So you have to add that in, but that obviously needs to start the virtual machine, stop the virtual machine, create it in the first place, because as I say, it's an appliance, it's a VM template. So we get into having some kind of infrastructure manager, and the manager has to manage something, and that's our network and hardware stack that the guest machine is going to sit on. Now, from a CloudStack point of view, that all looks really, really complicated, and we think, well, why would you want to do all that stuff? But it turns out, if you look at the model that we've had in CloudStack for way before that standard was probably even thought of, we have, taking our standard CloudStack model, we have our business logic here, our CloudStack kernel here, some adapters, and an actual network router, virtual network service provider. So our driver, if you like. And as you move through, you kind of look at it and go, oh, that fits actually quite very nicely on top of that model. All those pieces seem to be in exactly the same place. So we actually have already invented our own NFV ages ago. We just kind of didn't need to call it that. So at the end of the day, in this case, our VNF is just a guest instance in an NFV space, that's a virtual router, but with the second layer of orchestration. CloudStack infrastructure creates the virtual machine, and then something else is going in and configuring it for us. So we're not actually, in CloudStack terms, quite very far away from this NFV thing that people like to talk about, and we've got a lot of the building blocks already there. But there are some pieces missing, even in kind of that space for CloudStack. You can see that we've said it didn't used to be able to have layer 2 networks. Well, we've kind of been working on that, and we've sorted that one. We still need to have ranges of public IPs, rather than kind of getting them piecemeal one by one and then having to map them through to individual virtual machines. Most people want a pool of them where they do whatever they want. The place in CloudStack's networks, the virtual router is kind of fixed. It's always in the same place. You can't get it out the way very easily or move it to the side and still keep kind of functions that you'd want there. And also that virtual router, it's our virtual router. You can't put anything else there very easily, and just in terms of CloudStack orchestrate what it's doing. So Q are next generation networks, as we've now called them. And the purpose of them is to allow enterprises or corporate networks or people who want to do something other than the layout of a network that we currently do, allow them to replicate that in the cloud space, the virtual space. So a providers can, well, even an internal company can say, yeah, all that stuff you were doing with your physical stuff, and you had your servers, and you had your firewalls, and WAN accelerators, and all that, we can basically lift that up and replicate that in a cloud space. So, to get there, we're looking at, we've got to sort of change some bits in there. And I'll talk through the new concepts that we think we need to do that. And so we're going to introduce the idea of topologies, which I'll explain in a second. Then this enterprise topology to fit into that. A new type of virtual router, and I'll explain why we still need some kind of router in there. And then the new network types that we think would be appropriate, and then have a quick look at what we want to do and doing already with network appliances. So for the topologies, what we thought was, well, it's all kind of a bit confusing. If you've got an isolated network, is a kind of network. That's okay. Got that virtual router stuff on it. Shared network. Okay. Well, VPC, we kind of call it. It's a VPC network, but it's got a lot of networks. So we're kind of using the same term twice. Once for the kind of big thing around the outside, and then once for the little bits inside. And then if we go into this kind of enterprise topology idea, where there are networks all over the place, that's going to get really confusing. So we said, well, if we kind of move up a layer and say shared and isolated networks are actually a type of topology, a VPC is a type of topology, and then this enterprise network is a type of topology, we can then have all of them, and they kind of now have their nice little buckets and layers that they sit in. So then we move on to this idea of the enterprise topology, and obviously here it's vastly simplified versus the things that I'd shown before of what people might want to do. But simply here we have this router that I'll come back to, and then the idea, well, a user device, and that user device is likely in a lot of networks to be maybe a WAN accelerator, but it could be just a normal router via Brocade now, or Cisco, or whatever you want to put there. And then we said, well, then there might be this, you put a firewall there, maybe it's a virtual PIX firewall sitting there. Off that you might want this layer 2 network, which just doesn't have IP addresses. I'll come on to explaining more about that in a moment. And that would be your DMZ. You would tell the PIX that interface is the DMZ, and then you'll have your corporate network in here, for instance, and those could all go off in different ways and do different things. And that's just a very simple corporate implementation. So we said, well, okay, so we've now got these topologies, these different types of shapes of networks combined together. We've got the idea that we're going to have an enterprise one, but we still need to get data from our public space down to these networks. We can't just let people kind of say, well, use this IP address, I'm sure it'll be fine, or this is your range, oh, please don't use any other ones because they're using that. That's not going to work, well, not for long. You're going to have to protect other users from malicious or accidental people basically picking up other people's IP addresses. We're going to have some way of doing that. And for that, we've said we'll have this enterprise virtual router, and what kind of networking people would call a handoff. So the handoff being, this is your cable. On the end of this cable is a whole load of IP addresses, and your next hop will be X. But what do you do with your cable? Plug it into whatever you want. You want to plug it into one VM? Okay, fine, do that. If you want to plug it into your appliance, your WAN accelerator, great. And then put behind that whatever you want, or you plug it straight to a router. The choice is all yours. But what that virtual router, its job is basically to get data, or the IP address is assigned, through itself as fast as it physically can, and make sure that it's stopping other people using your IP addresses, your public ones, and stopping you using other people's. And that's pretty much its own job. So it'd be vastly simplified, but it's got a very specific job in there. And so the south part of this, where the user starts to see something, this little line is almost just dangling down their network cable that you've given them, virtual network cable. We then say, this is the gateway that you would connect to. This is the range of IP addresses you can use. Go knock yourselves out. Do whatever you want. There will be some work we'll have to do above that with routing, so that the upper northbound routers know where to send traffic. We already have OSPF in CloudStack, so there's already support for that. So we'll look at either just using that for the moment or adding, was it BGP, to something to move you forward so that those routers can talk to the core routers and route traffic. So, now we've got some ideas and concepts of how it might all fit together. We still need to look at those networks, the little bits of glue that's sticking things together. And in a normal CloudStack world, you create a network, you're going to possibly get a virtual router. You can say you don't want a virtual router, but you will end up with a load of IP addresses you've got to assign. And CloudStack won't let you not assign IP addresses. If you assign a big range, you can't use that range elsewhere in CloudStack, it won't let you. If you assign a tiny little range, you'll deploy 4 virtual machines on there. Even though you're not using the IP addresses in that range, CloudStack will say, yeah, but I've run out of IP addresses now, you only gave me 4. I know you didn't expect to use them, but still only 4. So that's kind of very constricting and also very messy. So we came up with well, really what people just want is a VLAN. They want their network cable, they just can plug in wherever they want. Particularly for things like service chaining, where you're connecting purely one router to a WAN accelerator. That's just one cable between 2 places. You don't want a whole network, you just need a cable, effectively. And so by taking out all the IP addressing, you then leave it to people to use their own Active Directory or IPAM kind of solution for passing out IP addresses. Maybe people want to do them all statically. Doesn't really make sense, but maybe they do. But CloudStack is just giving you a network you can do what you like with. And then we thought, well, that's great, but some people do want something in the middle where CloudStack is giving out addresses and doing that kind of thing. So we can make it simple for them where they can put in their own router, their own whatever appliance, and we will just give out IP addresses, but we'll allow the user to tell us what that range is and what the gateway is. So they can have their router and say, right, I've created a router, I've put it on this IP address, I'm now creating a network connected to that, and the virtual router will be giving out the IP addresses with their router as their gateway, which it will then hop on out from. It's just to give people a bit of a head start if they don't want to then set up a Infoblocks or Active Directory from the start. Obviously, a Linux box would give out DHCP addresses just like anything else as well, but it's just a simple user network. And so we come kind of back to that drawing diagram I had earlier. So we now have our enterprise router, which is just effectively filtering traffic to make sure only the traffic that should get through does. Then someone was probably going to put their WAN accelerator there, which will probably connect to some other network somewhere else. They're going to put their virtual router, firewall, VPN device, whatever thing they want to put in there. And so then they could create their layer 2 network off that. And so that could be a DMZ where they're then putting farmer web servers in or something like that. And then off that, they'd create another L2 network. And in this case, where is it? Here we are. Someone would have an Active Directory doing their DNS, DHCP, and then some user instances connected off that in a Windows world. So But the idea is that this can sprawl all over the place. We can be putting networks wherever you like. This one could have a layer 2 network off and could be some other device. Basically, you come up with a topology you want, and you can connect anything and put in any appliance there that you want. And a simple network there was shown where someone's created this router of their own, and down here they've got the simple network, so that's dealing with the DNS and DHCP, and these guest instances are just being given the IP address assigned there as the gateway. Remembering that all of those IP addresses assigned inside that space are completely up to the user themselves. Whoever's designing this network can do whatever they like in that, and it's just everything's basically protected just there. It is like going to your ISP in with your whatever setup you've got, your corporate offices or data centers, and they are passing you the cable out of the router they've installed and said, right, do what you like. These are your addresses, do whatever you want. So, my another little digression. The layer 2 networks, they seemed really popular when we brought them out. We got a lot of questions about them, a lot of people were interested in them. But people also said, okay, but if we haven't got a virtual router, what about the user data and metadata? And we said, well, handily enough, the guys in UARCH have been doing a load of work on the config drive for kind of very similar reasons. So let's use that. The metadata in that config drive includes the instance's host name. But also, we kind of went around in a circle and said, okay, well, your VM can always go out to something else and ask that thing what it should do. That's how kind of configuration management often works with likes of Chef and Puppet. But then we said, but the VM that's just come up, the instance has to be able to identify itself to whatever system is going to give it its config. You can't just say, hi, here I am. Who am I? The thing go, well, I don't know, you tell me and I'll give you whatever packages and stuff you need. So you need that user data, metadata to get into the instance first to then kind of kickstart and carry on. Even IPAN systems, which you don't need to pass the MAC address to, they still need a host, a name to pin what they're going to set you up as. So the config drive is basically a tiny little ISO, a CD-ROM, effectively, as the guest instance sees it, that gets mounted in the second position of the kind of IDE stack, as it were. It can be stored on secondary storage, but there's also an option to have that put onto primary storage instead. The reason being is some people see it being on secondary as a little bit of a security risk. A lot of people can get at secondary storage. It's very easy to get stuff in and out of it. Whereas, particularly for block storage, if it's on primary storage, it's much harder to read this ISO and just see what's in it, which will obviously include a load of user data and metadata that people have sent. Inside this CD-ROM, there will be two directories. There'll be a CloudStack one, which contains all the CloudStack metadata as it would normally be passed, and, as it happens, an Openstack one. It's quite interesting. There's been a little bit of, normally we wouldn't dare lay a glove on Openstack, but people have heard this morning being quite bullish in there. Well, it's actually we're finding out we might be better after all. But we need a mechanism to get this data that's on a CD-ROM over here into our guest instance. Just because it's there, it doesn't get it. It doesn't do anything just because it's there. And the kind of saving grace there is Cloud Init. And Cloud Init started as an Ubuntu thing, and then they slowly ported it over to most of the major Linux OSs. And Cloudbase have done an open source to a Windows version, so pretty much everyone's covered there. And Cloud Init is allowed to have different data sources, and there are a whole load of them. Obviously, AWS and Azure and Google Cloud data sources, so they can pick up data from there. But there is actually a built-in CloudStack one, but that's expecting to find the virtual router. But there is also a config drive variant of the data sources. And so The config drive uses the Openstack configuration for a drive disk configuration drive disk. They have their own setup of what you can put in and where it goes. So, and going on to a massive now digression, I was trying to find just some documentation that gave me the layout, and I could have opened one of the config drives and looked to see where all the bits of file went. But I thought, oh, there must be just some documentation. I'll have a nice little picture or something. I'll just get hold of that. And then I went to the Openstack user guides and found 2, 4, 6, 8, 10, 12, 14, 16, 18, 19 different user guides. I looked and thought, oh, it's not bare metal. Compute, it could be, because that's where it starts. Container, I don't think it's that. Dashboard, probably not. Data, no. And I decided, oh well, that's what I'm going to put down. A shrug. I don't know. But what I do know is it does work. If you use config drive with the layer 2 networks, it will get its host name, it will get all the user data passed to it that via cloud in it. It does work kind of how it's supposed to. So that's the end of my Openstack, or nudge there. So, getting towards the end, if we get back to our layer 2 networks again, our next step is to look at them, and we've got a few users who do that, who use the layer 2 networks, and want to use it with systems such as Infoblocks. And I've started conversations with Infoblocks about what we might do with them. There are 2 ways in which you could pass data. There is Infoblocks telling CloudStack what IP addresses it's assigned to a VM, because people kind of still like to see their IP address in the CloudStack UI. But also, if they're integrating, they also want to be able to say, oh, that VM, what is its IP address via the CloudStack API? People love that CloudStack API. And now suddenly the IP address isn't there because it was assigned over there. So we could suck that back in. Or we could do it the other way around, which is where we create the virtual machine and we quickly tell your IPAM, your Infoblocks, we've created this virtual machine with this MAC address. Be warned, set up your record for that, so when the machine appears, it says, it sees the MAC address, understands it, and assigns it the name that CloudStack said to assign. But it was Infoblocks that drove just actually assigns the IP addresses and decides what was getting what. So that's the kind of next step with the layer 2 stuff. And I think now just a brief look at the network appliances, because we went over them. And as I said before, they are still just basically guest instances. You can go and download, for VMware, often most of them are, an OVA. And you download it and you send it to vCenter and it pops up and says, here I am now a Cisco or Netscaler or whatever it happens to be. But in CloudStack, we thought, well, people probably don't want those appearing in their list of virtual machines. They're kind of a different thing. And we certainly don't want, probably, some of a company wouldn't want their users start seeing this virtual machine in there and playing with it. We want it somewhere else, and we want it to appear in our list of network things. So we're going to have to just put some kind of flag in somewhere to say these are network appliances of some sort. But also, network appliances often have multiple disks, which is a bit of a problem for us. So we wanted to deal with that. And also, I'll show example in a second, extra configuration data. The network appliances often need some knowledge more than just how many CPU and how much RAM. They'll have been specially designed in some way to do more than just be effectively another guest instance. There's going to be other stuff going on, but there always is. So, to look at an example of this Cisco RSA, there is just a single line of what it calls extra config here, which needs to be passed into the startup, the VMX, that kind of defines the virtual machine in the first place. There's also a whole load of questions it asks about what's my host name supposed to be, actually what's my IP address supposed to be, how many interfaces do you want me to have, all sorts of things that are questions that are stored in the, if you like, template itself, and when you deploy it, you get asked, and then the VMware environment, the vCenter, will inject all of that into the final VMX, the scripter of the machine. So we need to deal with that stuff to really be able to use network appliances. Well, we've got the building blocks taking shape. We already have multi-disk OVAs that we can import. So there's a pull, show a pull request there against master, so that's, I think, been merged, so that's there already. Very shortly, in probably the next couple of weeks, we'll have the pull request in for sending extra configuration data to virtual machines. That's been worked on by Dengane, if he's in and about somewhere. And that's going to work for KVM, VMware, and Zen Server. There will be a security around that where you've got global settings to say whether an administrator can pass extra data to a VM and whether a user is allowed to. Probably at some point we'll get more granular and you'll say particular users or particular accounts can and can't, because obviously you can do damage if you start passing low-level hardware stuff through to a virtual machine, start it up, it can start getting in the way. But that will become a choice of the cloud operator, whether that's even allowed by anybody or not. It will all depend on what their use case for this kind of feature would be. It's also, so that is generic. It means anything you want to add to that VMX or to the XML of a KVM machine, you can add at startup and just say, this is extra stuff I want you to store and always pass through when you start this virtual machine. So that was my kind of overview of where we're trying to go and what we're trying to do with these networks. It makes it's a very good onboarding for corporates, and various companies are trying to do more than just the network piece to start off with. Maybe their end game will actually be some kind of container services and what have you, but they still have their, let's call it legacy, everyone likes to, their legacy infrastructure, which they could basically lift up, keep all of the expertise and knowledge that they have, and maybe all the licensing they're paid for, and move it into the cloud. Just lift it up, copy it over here, and do the same again, and maybe even reusing bits of config they had before. And that's going to allow an adoption, and then they can sit in this cloud space and start creating containers as well, maybe connecting that into that network, and then figure out, actually, we can get rid of those services that used to run and containerize those, and you can migrate rather than have to have a big bang move over. And also it fits all the people who may not be looking to make any kind of change anytime soon, and just go, well, if I can have all the stuff I had here, but have it in the cloud, and I don't have to do it someone else's way. I can carry on doing it the way I've always done it, but now it's virtualized. That's the kind of direction we're kind of trying to take all of this at the moment. It doesn't replace and mean that anything that used to be there has to go or will go. It just gives another option of how people can work with CloudStack and create networks and do whatever it is they want to drive. Any questions on that, please? Awesome. So the obligatory, we're hiring. So if you know people who are looking to work on CloudStack, work on features, just write codes and do stuff, make some of this kind of thing happen, and some of the other stuff that people from Blue will be talking about, please come and see, preferably me, because there's little bonuses in it to be introduced, so just me, only me. That would be great. I'll buy you a beer or something. And that was it. Thank you very much.